Okay, here's our second day on solving systems by substitution. That's why it's 1.5.2. We've talked about solving by substitution. Today we're going to make the equations a little bit more complicated. We're going to solve by substitution when a variable isn't yet isolated. That means when it's not all by itself. Like so far we've been doing things like y equals 2x plus 3, and then blah blah blah. And because the y is already isolated all by itself on one side of the equation, it was pretty simple to just take what it was equal to and plug it into whatever the other equation was. Well, that's not going to be the case today. It's frequently not the case where you have an easy variable that's just already solved for. We also want to identify which variable will be best to solve for when we have to choose, and briefly discuss the situations of no solutions and infinite solutions. No solutions, you remember, is when you have two parallel lines. Infinite solutions is when you have the same line twice. Okay, so because we're lazy, and we are, right? Like mathematicians are notoriously and by definition lazy because we try to do things as easily as possible whenever we can. In fact, a mathematician will work incredibly hard to make something just a little bit easier. And that seems like a contradiction, but it's actually how things work. So because we are lazy and want to make this as easy as possible, we avoid fractions at all costs. We avoid extra steps, and if possible, we avoid negatives. You can't always avoid negatives. You also can't always avoid fractions, but we can work really hard to avoid these things. So take a look at this system right here. 2x plus 3y equals 10, and x minus 4y equals negative 6. I need to identify which variable is the best one to isolate, which means I have to solve for one of these variables. Now, we're going to rely heavily on this important word in math, which is coefficient. Coefficient is basically a fancy way of saying the number that multiplies a variable, or the number in front of a variable. So on this x, the coefficient is 2. And on this y, the coefficient is 3. And on this y, the coefficient is negative 4. And the fact that it's negative 4 is really important. Hang on to the negative part of that. The sign, positive, negative, is crucially important. But on this x right here, the coefficient is 1. If there's nothing written there, the coefficient is 1. We're going to solve for this x right here because it has a coefficient of 1. And that means it'll take fewer steps and also probably not involve fractions. So to solve for this x, I get rid of the other term. I'm going to add 4y to both sides. That becomes x equals, I'm going to put the y in front, 4y minus 6. If you write negative 6 plus 4y, it's the same thing, it doesn't matter. I have now solved for one of my variables, and that's the first thing I need to make happen. Identify which variable to solve and solve for it. Now I'm going to take what it's equal to, x equals 4y minus 6, and plug it into the other x. It has to be the x in the other equation. You can't use the one that you started with. It has to be the other equation. So I'm going to have 2, and this x became 4y minus 6 plus 3y equals 10. So it used to be 2x plus 3y, now it's 2 times 4y minus 6 plus 3y. I do some distributing. We get 8y minus 6, minus 12, 8y minus 12 plus 3y equals 10. Combine like terms, so 8y and 3y can go together, and we get 11y minus 12 equals 10. Add 12 to both sides, and we have 11y equals 22. Divide both sides by 11, and we get that y equals 2. All right, we got a nice clean whole number here, y equals 2. Since I know that y equals 2, I'm going to plug it into this equation here, the one that I have in this box. This will involve the fewest number of steps. I could plug it into this y right here. I could plug it into this y right here. But I want to pick the one that already has the x by itself, the one that already has x isolated. So I'm going to take y equals 2 and plug it in here. So this is usually the equation, like initially the equation, x equals 4y minus 6. But I'm going to take that y and turn it into a 2, because y is 2. That's what this says, y is 2. So that means that x equals 8 minus 6. so x equals 2. My solution is the point 2, 2. If I check that really quick, 2 times 2 is, so I'm plugging a 2 in for x and a 2 in for y. Remember, always check it in the equation that you didn't use. So I just used this one to find x, so I'm not going to use it to check. I'm going to use this one to check. So if x is 2 and y is 2, that becomes 4 plus 6, which is 10. And it was supposed to be 10. My solution is the point 2, 2. So the key to solving these systems is going to be, how do we best identify which variable to solve for? That's the key. If you have a coefficient of 1 or negative 1, really, really helpful. So here's another example. I want to identify which variable is best to solve for. This has a coefficient of negative 1. So that's the one I'm going to choose. Anytime you can find plus or minus 1, pick that one. So I'm going to get this y by itself. I'm going to take the equation and write it down here. 2x minus y equals 20. I'll first subtract 2x from both sides. And that gives me negative y equals negative 2x plus 20. That was a positive 20, so I put plus 20. Notice how this is still negative y. The negative doesn't go anywhere. Negatives are going to be the biggest frustration with, well, all of math probably, but definitely with substitution. In fact, my next video will just be practicing negatives and having strategies for negatives. But think of this like it's negative 1 times y. That's really what that means. So I'm going to divide both sides by negative 1, or multiply both sides by negative 1. It's the same thing. And that becomes y equals positive 2x minus 20. Now the y is truly isolated. The negative in front of it is gone, and the 2x in front of it is gone. The y is truly isolated. So I'm going to take what it's equal to, 2x minus 20, and plug it into the other equation, not the first one, the one that I haven't used yet. I plug it into the other equation. So that gives me 3x plus 4 times y, and y is 2x minus 20, which equals negative 36. Okay, I'm going to solve this for x now. I found what y is equal to, but I've got to go through and find x now. So I get 3x plus 8x minus 80 equals negative 36. Combine my like terms. 11x minus 80 equals negative 36. Add 80 to both sides. Negative 36 plus 80 is 44. So 11x equals 44. Divide both sides by 11 and x equals 4. Okay, this feels like a lot of substitutions happening, and it is. We just found x. Now we've got to find y. Let's go back into this equation. Y equals 2 times 4 minus 20, which means that y equals 8 minus 20, so y is negative 12. Our solution is the point 4, negative 12. Okay, I'm going to check that. I'm going to check it in which equation? I'm going to check it in this one, because I did most of my work with this one. So I'm going to check it in 3x plus 4y equals negative 36. I'm going to try to create some space here. 3x plus 4y equals negative 36. Well, that's 3 times 4 plus 4 times negative 12. That should come out to negative 36. 12 minus 48 is negative 36. Bingo, we got it. We have the correct solution. Identify which variable to solve for it, and then do your substitution. These three we're not actually going to solve for, but I do want us to discuss which variable should we isolate first. Okay, so take a look at these three systems. I'll call them systems 1, 2, and 3. See if you can identify which variable is the best one to isolate in each system. Pause it, take a minute, choose. For number 1, it's clearly the y on top. It has a coefficient of 1. For number 2, it's clearly the x on the bottom. It has a coefficient of 1. Awesome. For number 3, it's way less clear. None of these have a coefficient of 1 or negative 1, which means it's not quite as obvious. So here's what we look for. We look at the coefficients and we kind of just do this quick check. I'm going to ask myself the question, if I divided every term here by 3, would I ever get a fraction? And the answer is yes. If I divide 4 by 3, I get a fraction. I don't want that. Okay, that's no good. If I divide everything by 4 in this equation, will I get a fraction? Well, yeah, since 4 is bigger than 3, if I divide 3 by 4, if I'm dividing everything by 4, then I'm definitely going to get a fraction. So I don't want to pick the x or the y on top. You'll also notice, if I divide by 6 everywhere, I get a fraction here of 1/3 and a fraction here of 4/3. I don't like that. But if I divide everything by 2, okay. Now I have x plus 3y equals 4. I should get this x by itself, because I subtract the 3y from both sides. Now I've solved for x. So, if the coefficient isn't 1, what I recommend you do is in each equation, find the lowest coefficient. So in the top equation that was 3, and in the bottom equation that was 2. Find the lowest coefficient, and see if you can divide by it and not make a fraction. Okay, if I divide everything by 2, I don't make a fraction here, so I should choose to get this x by itself. Subtract the 6y from both sides, divide everything by 2. Or divide everything by 2 first, then subtract the 3y from both sides, doesn't matter. So hopefully you can have a coefficient that's plus or minus 1. If not, find one that you can divide and get a clean solution. So we'll do 2 more examples, and then we're done. We're going to talk about parallel lines and infinite solutions. So no solutions and infinite solutions. Notice how here, the y is already solved for. That's sweet. And notice how this is in slope-intercept form. These both have the same slope of 15. Since they have the same slope of 15, but they have different y-intercepts, one is at 30 and one is at negative 11, we know these are parallel lines and they have no solutions. But I want to show you how the math works, because sometimes that won't always be obvious. Sometimes you won't see that it's no solutions because you're not in slope-intercept form. So you have to see how the math turns out. I'm going to take one y and plug it into the other. So this becomes 15x minus 11 equals 15x plus 30. Now I'm going to subtract 15x from both sides. That becomes negative 11 equals 30. Now notice how this has no variables. That's a key thing. If you start solving and the variables just go away, if you have no variables, that means you're going to have either no solutions or infinite solutions. One of those two things is possible. This is a lie. Just so you know, negative 11 is not the same as 30. Negative 11 does not equal 30. This is a lie. If you're being lied to, no solutions. If you have something like 0 equals 2, 15 equals 8, negative 1 equals 1, some non-true statement without a variable, that's key, there's no variable left, it's going to be no solutions. If you get a true statement, like 3 equals 3, 10 equals 10, 0 equals 0, and again, there's still no variables anywhere, then this will have infinite solutions. Okay, this is no solutions, this is infinite solutions. Understand the difference. Infinite solutions means basically you have the same line twice. That'll be what happens here. This one will work out to be infinite. Okay, I need to identify which variable should I solve for. I choose to solve for this y, because if I divide everything by 2, I get whole numbers. 10 divided by 2 is 5, 4 divided by 2 is 2. So I'm going to take this y and isolate it. So off to the side, I'm going to write out the equation, 4x plus 2y equals 10. I'll first subtract 4x from both sides, and that gives me 2y equals a negative 4x plus 10. Divide everything by 2, and y equals negative 2x plus 5. Okay, I've solved for y. I'm going to take what it's equal to and plug it into the other equation. Although I'm going to keep changing colors. I think that's important. I recommend you do the same. Take what it's equal to and plug it into the other equation. So this becomes 6x plus 3 times y, but y is now negative 2x plus 5. And that equals 15. I do some distribution. 6x minus 6x plus 15 equals 15. These two 6x's combine to 0. 6x minus 6x is actually 0x. And don't bother writing 0x. 0x is just 0. So this is just going to be 15 equals 15. There's no variable. That's still so important. There's no variable. And this is a true statement. That means this has infinite solutions. We could say that x and y is in the set of all real numbers, if we were so inclined. But if you just write infinite, I'll be okay with that. Big ol' recap here. Solve by substitution, isolate a variable, plug what it's equal to into the other equation. Okay, that's review for us. Make sure to find both the variables, x and y, or a and b, whatever they are. Being able to identify which variable is the easiest to solve for is a very high value. Pick the one that has a coefficient of plus or minus 1. If that's not available, pick whichever one divides the cleanest. If you end up with a true statement that has no variables, like 0 equals 0, 6 equals 6, that means you have infinite solutions. If you end up with a false statement that has no variables, like 0 equals 3 or 6 equals 2, that means you have no solutions. Always be sure to check your answer when possible. In the next video, we're going to get some more practice, maybe do some word problems, and we'll really focus on negatives, how to deal with just lots and lots of negatives. Thanks for watching. See you then.